In the past, we've talked about completing the square. Now we're going to see how you can solve an equation using your completing the square. So the steps are from a quadratic expression equaling a constant. Now normally this constant in many times would just be set equal to 0, but I'm showing you how to do it from a constant because then this could be like 7 or 8 or negative 12 or even a fraction. It's just saying we have a quadratic set equal to just a number. If there were extra variables here, you need to multiply or add or subtract, whatever. You got to get them over to this side. So it's just quadratic equals a constant. Once we have it set up this way, you divide a from both sides. So this term, this term, this term, this term, divided by a. That way, this is just x squared. There's no coefficient in front of it. Next step is you subtract the constant, the one on the quadratic side, from both sides. Now remember, this isn't c anymore, it's c over a, right? We divided this a. So you're subtracting that from both sides. Next thing you do, you add that b over 2 squared to both sides. Again, you can think of this as b divided by 2. You can think of it as half of b. But then once you find that half of b, you square it, and that's what you're adding on to both sides. This side you will simplify. This side, the one that has all the x's still, you rewrite as a binomial squared. To get rid of that squared, we square root on both sides of the equation, and then you subtract the constant from your binomial to get x alone. Let's see how that works in an example. We start with this equation, x squared plus 6x plus 10 equals 4. Our first step, remember, is to divide a from both sides. Now in this case, our a is 1, so dividing by a doesn't really change anything. The next thing we need to do is subtract the constant. In this case, it is 10, so we're going to subtract 10 from both sides. Let's get rid of that, and get rid of that. When we subtract the 10 from both sides, now it's just x squared plus 6x equals negative 6. 4 minus 10 gives us a negative 6. Now we're going to add half of b squared to both sides of the equation. b is 6. Half of 6 is 3. 3 squared is 9, so we're adding 9 to both sides of the equation. I'm going to move that down just a little bit so you can see. We added 9 to both sides. This side is now a perfect square trinomial. This side is just two constants. I can add them together and simplify. So when I simplify this side, it becomes positive 3. When I rewrite this side, it's x plus 3 squared. How did I know it was a plus 3? Well, again, it's half of this one, or it's the square root of this one. X plus 3 squared. This one will always be positive. So the way to know whether this is plus or minus is you have to look at this one. If this was a minus 6, we'd have a minus 3. Since this is plus 6, we have a plus 3. Once it is a binomial squared, we square root both sides to get rid of that squared piece. Take the square root of this and it cancels out our squared. Square root of 3 is just positive or negative square root 3. Again, the reason I have a positive or negative is because like a negative 4 squared is 16, a positive 4 squared is 16. So there's a positive and a negative form of this square root. We want x alone, so I subtract 3 from both sides, and I call it negative 3. So negative 3 plus or minus the square root of 3 would be my answer for x. Okay? Again, this is showing me two separate solutions, two answers that would work. If I typed it out in my calculator, negative 3 plus the square root of 3, I would get this. And again, this is rounded to the nearest 10,000th. If I did negative 3 minus the square root of 3, and you can just type that into a calculator, round it to the nearest 10,000th, and you would get negative 4.7321. So these are my two answers for x rounded to the nearest 10,000th. If they wanted it in exact form, this is your exact form. Negative 3 plus or minus the square root of 3. Now you might be thinking, gosh, this is just getting ridiculous. Well, it is. This is definitely ridiculous. But let's try it again. We're going to do another example. This time again, notice from last time to this time, the a value is no longer 1. All we're going to do is the same exact steps, just using an a value that is not 1. First step, divide a from both sides. All of these terms are being divided by 3. 3 goes away for this one. We call this now 8/3 times x. We call this now 12/3 and 4/3. Now I know that 12 divided by 3 is 4, so I could call this 4 if I wanted to. I'm going to leave it as 12/3, and I'll show you why. When I subtract the constant from my quadratic side from both sides, which technically in this case I'm adding it because this is negative, so I'm going to add 12/3 to both sides. It would look something like this. I still have my x squared plus 8/3 x. That was here. I added 12/3 to both sides. 4/3 plus 12/3. I left it in thirds because 4/3 and 12/3 I can add and just call it 16/3. So x squared plus 8/3 x equals 16/3. Now looking at my b value, 8/3, I need half of that. How do you find half of a fraction? I'm going to do that actually up here. 8/3, and I want half of that. So you just multiply by a half. 8 times 1 is 8. 3 times 2 is 6. So we have 8/6. That is what I would be adding on to both sides. Oops, actually, that's not what I'm adding on to both sides yet. I need to square that. Before I square it, though, it might be nice to simplify this. 8/6, I can take 2 out of each. We call it 4/3. 8/6 is 4/3. I square this. So this whole thing is being squared. 4 squared is 16. 3 squared is 9. So it's 16/9 that I'm adding to both sides. X squared plus 8/3 x plus 16/9 equals this 16/3 that we had from before plus 16/9. Now again, because we're working with fractions, you got a 3 here and you got a 9. If we want to add these, I need to turn this into ninths. So I multiply both of those. This 16 multiplied by 3, this 3 multiplied by 3. That way my bottom is a 9. My top would then become 48. 48 ninths plus 16 ninths becomes 64 ninths. So here is my simplified form of this side. This side we need to rewrite as a binomial squared. What did we say was half of 8/3? That 4/3. So x plus 4/3 squared equals our 64 ninths. Okay, it does get a little messy sometimes when you're working with an a value that is not 1. That's okay. Push through it, and it'll get nicer at the end. To get rid of this squared, we do the square root of both sides. So square rooting both sides, x plus 4/3 equals positive or negative square root of 64/9. Now if you're square rooting a fraction, the square root applies to each piece separately. Square root of 64 is 8, square root of 9 is 3, so this becomes 8/3, positive or negative 8/3. We subtract this piece, the 4/3, from both sides, so that we have negative 4/3, either plus or minus 8/3. So what is negative 4/3 plus 8/3? Well, it would be 4/3. What's negative 4/3 minus 8/3? Well, that would be negative 12/3. So these are our two options. And again, if they wanted it rounded to the nearest 10,000th, 4/3 is the same as 1 1/3 or 1.3 repeating. Negative 12/3 is just negative 4. So this one actually simplifies a lot better than our last one did. Even though, yes, there are some fractions to work with, that's all right. Push through it to the end, and you'll get your answer. Now, again, this is getting ridiculous, but we're going to try it one more time using another a is not 1. So, starting with negative 4x squared plus 40x minus 28 equals 8. First thing we do is divide a from both sides. So in this case, I'm going to show you what happens if you don't put them as fractions. Okay, it's okay if everything happens to divide out evenly. Just get them back into those whole numbers. We divide by negative 4. This 40 becomes negative 10. This minus 28 becomes plus 7. This 8 becomes negative 2. Subtract the constant that was on this quadratic side. So get rid of this 7. Negative 2 minus 7 becomes negative 9. Add half of b squared to both sides. Half of b would be negative 5. Negative 5 squared, so negative 5 times negative 5, is 25. So we're adding 25 to both sides. This side I can rewrite as a binomial squared. X minus 5, I know to use minus because this is a negative 10, minus 5 squared. This side I can simplify to 16. I square root both sides to get rid of the square, and I get x minus 5 equals positive or negative square root of 16, which, by the way, square root of 16 is just 4. Lastly, I add the 5 onto both sides, so I have x equals 5 plus or minus 4. 5 plus 4 would be 9. 5 minus 4 would be 1. So here are my two options. So that'll cover it for our second video. We discussed how to solve a quadratic function by completing the square.